All right, Marshall, you got something?
And -3 bracket infinity parentheses.
Okay, and what about the range?
-5 bracket and infinity parentheses.
All right, good. Because what does +3 do to the graph? Moves it which way?
Left.
Left 3 and -5 moves it
Down 5.
down 5. Okay. And now the original graph is f of x equals square root of x, which hopefully after going through it yesterday, you're a little bit more familiar with it. It's at 0, 0, 1, 1. Square root of 4 is 2. And then square root of 9 is 3. It does increase gradually. And it will eventually, keep going all the way to infinity, both out to the right and in the y direction as well. So that's going to get moved 3 to the left, 5 down for that. Now you went through those guided notes yesterday. Questions there on anything from the notes? Hold on, let me grab a copy. From the notes or from the homework. Let me just hit a couple quick things here just to make sure. If you have a negative, where it goes will depend on how it's reflected. Okay, if it's outside like the absolute values or outside the quantity, it does one thing. If it's with the x, it does a separate thing. What about the top one? Where does that reflect it across?
The x-axis.
Okay, it reflects it across the x-axis. What I do is, since it's on the outside, what it does is it changes the y value from positive to negative. So if you change the y value from positive to negative, okay, it flips it. It's going to take it across the x-axis. So this is x-axis. Well, then therefore that means this one's going to be the y-axis. If the negative's with the x, it changes the coordinate of the x term. So it's going to flip it across the y-axis there. Reflections. How do you reflect something vertically? How would I not reflect, how would I stretch that vertically? What would be a constant, and where would it be to stretch that vertically? Okay, Adam, what do you think?
Stretch vertically, it would be out before the absolute value.
Give me a number.
2.
So that would stretch it. What would compress it vertically? Okay.
By having a fraction inside the absolute value.
Not vertically. It'd still be outside. So if it's outside, it would be, so like y equals 1/3 absolute value of x. So that would compress it vertically. All right, well, what about horizontally? How is that different? So if you got y equals the absolute value of 2x, what is that going to do? What's that?
Half.
Well, I'm going to do a half next. But what if it is 2x? What does that actually do?
Compresses it.
Compresses it. So horizontally, it's a little bit backwards. So that will compress by what factor? You take 1 divided by whatever that is, by a factor of 1/2. And if I got y equals absolute value of 1/2 x, that will stretch it by a factor of 2. Okay. All right. Sounds good. Most of what you did was one translation yesterday, one transformation, with the exception of maybe vertically and horizontally. When you start doing more than one transformation, things get a little bit hairy. All right, this isn't on your guided notes, but just pay attention. According to this, what's happening? Negative absolute value of x plus 2. Plus 2 moves it which way? Up 2. What's the negative in front? It reflects it over the x-axis. So now, if I move it up 2 and then reflect it over the x-axis, I get that graph. If I reflect it first and then move it, move it up 2, I get a different graph. Okay, those are not the same graph. So that means order is very important. You just can't randomly pick how you're going to transform it. You can't just flip it and then move it up, or move it up and then flip it. You get two different answers. Which one is right? Well, for this one, I can at least plug a number and check. What happens when you plug in 0? What answer do we get? Get 2, right? So is that can this one be right? No, because that says 0, -2. And this one says 0, 2. So that second one's right. So what do we have to do first? We have to reflect it and then move it up. All right. Now there's a nice little some steps that will help us keep our transformations kind of in order. And I go by this. Like, transformations to me are not easy. If you're just looking at an equation, if you're trying to see which way am I going to go first, how it's affected, it can be complicated. This kind of simplifies things. If you perform these in the following order, you're going to be good. You go horizontal shift first. You go stretch or compress second. You go reflections third. And then the last thing is a vertical shift. Would be the fourth thing. Little saying to help you remember this, courtesy of Jim Bradkovich. That's it. It's been a while. High school RV. It doesn't really mean anything. High school, H for horizontal. SC, school for stretch compressed, and then RVs, everybody's recreational vehicle. So remember it in that order. Horizontal, stretch or compress, reflect, vertical shift. Okay, you do that, and then you'll be good. Let's take a look at a case here. Now, this again, I'm going to stress this like I did yesterday. You got to give me some points, and 3 is a minimum. In this case, we're going to do 5 because otherwise, I don't want like 1 point and then just like a parabola sketched in there. We need some exact things. All right, what's going on with this function? Let me do one thing because this tends to throw people off, but you need to be able to take an equation like this and understand what's going on. I could also write this as f of x equals negative quantity x plus 2 squared plus 5. When I write it that way, everybody says, yeah, 5 is a vertical shift. When it's written this way, a lot of times 5, you want to think of it as a multiple and think it's a stretch or compress. It's not, okay, because it's being added. All right, what's going on here? Is there a horizontal shift? Dakota, we'll go with you.
Yes.
Which way?
Up 5.
That's not horizontal.
Horizontal, yeah. Left 2.
Left 2, that's horizontal. Good. So left 2. And if you try to do the vertical first, then it'll be all jacked up. Stretch or compress? Is there anything there? Matthew? No, there's not. So is there reflection? Lizzie, reflection.
Over the x-axis.
Over the x-axis. So it reflects over the x-axis. So reflect. Over the x-axis. And vertical shift, Dakota helped us out with that. It's going to go up 5. So we got left 2, reflect over the x-axis, up 5. Now you can graph the whole thing and try to do it all at once. You can go point by point. I'm going to graph the parent function, which is just going to be y equals x squared. So I'm going to graph it 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Those 5 points should be enough. Now with a parabola, it's not too bad to kind of like visualize. All right, I can move it left 2, I can reflect it, and I can move it up. Sometimes you're not going to have that easy of a graph to work with. I'm going to go point by point. Okay, you can do this one at a time. So I want to take the vertex, which is 0, 0. You go left 2, and I'm going to end up erasing these. Left 2. Well, reflect over the x-axis. Well, if it's on the x-axis, you can't reflect over. It stays there. And then you move it up 5. So where's that point going to end up at? It's going to end up at negative 2, 5. Okay, that's going to be that point. One nice thing, if I got the equation, you can substitute it in and see if it works. Well, what happens when you substitute in negative 2? Negative 2 plus 2 is 0. 0 squared, 0. And you get 5 minus 0, which is 5. So you know you're right. All right, let's move those other points. So I'm going to use negative 1, 1. I'm going to move it left 2. So it's at negative 3, 1. When I reflect it over the x-axis, it goes to negative 3, negative 1. And I go up 1, 2, 3, 4, 5. Okay, I'm now at negative 3, positive 4. And I'm going to go to 1, 1, which is right. I'm going to go left 2, which puts me at negative 1, 1. Down, reflect over the x-axis. And then it looks like I end up at negative 1, 4. All right, go ahead and move your other 2 points. Figure out where they're going to be. And let's see where they're going to be. Right here, left 2. All right, it's at negative 4, 4. So when I reflect it down there, it goes down to negative 4, negative 4. And I go up 1, 2, 3, 4, 5. Is that right? I don't think that's right.
Yeah.
No, that's right. Negative 4, 1. Okay. And then is the other one going to be 0, 1? Okay, so there's your graph. There's your graph. All right, second one. All right, copy that down, and I want you to list what's happening. List all of the transformations that's occurring. And go in that high school RV format. All right, what's happening? Okay, in this case here, Matthew.
You go left 4.
Left 4. Got it.
Then there's a horizontal compression by 1/2.
Good. Horizontal compression.
There's an x-axis reflection.
Hold on here. Let me catch up. By 1/2. That negative on the outside reflects over the x-axis. And then what else?
Just up 3.
Up 3?
Yep.
Okay. Up 3. So we got 4 things going on. So, all right. We got the square root of x. That's our parent function. I'm going to graph that. Y equals square root of x. And it's at 0, 0, 1, 1, 4, 2, and I can fit 9, 3 on here. So I want to graph these 4 points. Okay, so it's going to increase to the right there. All right, start at 0, 0, go left 4, horizontal compression by 1/2. All right, before I do this, how does a horizontal compression work? So let's say if you got a point at 6, negative 3, where's that going to move to on a horizontal compression? Okay, let's see.
3.
It's going to go to 3. It's going to go, if you're going to go by 1/2, it's going to go 1/2 closer to the x-axis. So it's going to go to 3. If I got a point at, if I compress this point, 3, negative 3, by 1/2, it's going to go to 1.5. So it's going to go halfway towards the x-axis. If it's a stretch, then it's going to go away from the x-axis, but it doesn't move up or down. Doesn't move up or down. So it's going to compress in towards the x-axis. So 0, 0 moves left 4. I'll go back and erase these. So it's at -4. Compress it by a half. So where's it going to take it to? -2. Reflect over the x-axis. Well, I'm on the x-axis, so there's no reflection. And it goes which direction? Up 3. So I go up 1, 2, 3. Now, since I do have an equation, if I plug in -2, I better get back 3. All right, test it. Just do mentally here. 2 times -2 is -4. -4 plus 4 is 0. So that whole thing is 0. Add 3, you end up at 3. So that makes sense. All right, so 1, 1. Go left 4. 1, 2, 3, 4. It takes me to -3, 1. Compress it by a half. Just a half towards the x-axis. So it's at -3, so it's going to go where? -1.5. Reflect over the x-axis. That will reflect over to -1.5, -1. And now I go up 3. So I go up 1, 2, 3. That's my final landing spot. And it looks like it's at -1.5. I'm actually going to list these points. Let's see here. X, Y. So I had -2, 3. I got -1.5, 2. All right, see what you get for the next 2 points. See what you get for the next 2 points. And I'm just going to do this one here. 4, 2, I go left 4. So it puts me on the axis. So you can't compress it at all. Okay, because it's on the axis. Reflect over the x-axis. Well, that'll take me to 0, -2. And then if I move up 3, looks like I get 0, 1. Okay, for that. And then the last point, which was 9, 3. What did you end up with for 9, 3? Marissa, you got that?
Is it 2.5, 0?
She says 2.5, 0. Do we agree? All right, I get Brooke says yeah. So let's take a look. So 9. I move left 4 from 9, 3. So 1, 2, 3, 4. So I'm at 5. Cut that 5.5 and it puts me at 2.5. Reflect over, so 2.5, -3, move up 3. 2.5, 0 looks right. Now make sure you connect. Okay. So it's upside down because that's the reflection over the x-axis. When you have, if you don't have like a circle or something of that nature, it's easy to see like the compression or the stretch. If you just have like a graph like the square root, it's not going to be as obvious on the compression. It doesn't look as clear for that. All right, what I need you to do now, turn to page 279. Turn to page 279. I'm going to give you a handout here. And we're going to look at 109 through 118.
Yeah, no, I just had a random packet in my book and was trying to figure out what it was.
Oh.
That's all.
You have the equation, in my opinion, is easier. My opinion doesn't mean a whole lot to them. If you look at 109, they're just going to give you a graph. And they're going to call it f of x. There's no equation attached to it. So I think, to me, this is a little more difficult. Because you don't have an equation that you can plug into and verify whether the point you put down is correct. So there, at the top left, what they list on there is, this is your parent function. Copy that down up here. Copy that down so you have that to work with. It's the point -4, -2, 1, 2, 3, -1, 5, 4. So just connecting those. So we're going to do different transformations for each one. That's your parent function. And we're going to use that one for each problem here, 109 through 118. All right, let's just kind of go through the first couple ones, just make sure you're good there. That's called f of x. You don't know what the function is, it doesn't matter. So for 109, it just says f of x plus 1. What does the plus 1 do? Moves everything up 1. So just move everything up 1. So obviously I got the answer there. In some cases, I might ask you to write the ordered pairs if you need to, or if you're asked to, make sure you're able to do that. So -4, -2 moves up to -4, -1. These are just slightly off. Okay, so -4. Whoops. Now, how about 110? -2 f of x. What's the -2 going to do? It's, Holly, what do you think? What's the 2 going to do?
Vertically stretch it.
Vertically stretch it, which changes your y coordinate. What's the negative going to do in front of the 2?
Reflected.
Yep, reflected over which axis?
The x-axis.
X-axis. Okay, so what was that first point? -4, -2. So it's at -4, -2. It's going to be stretched. At -2, it's going to stretch away to -4. And then at -4, it's going to reflect over the x-axis. So it looks like here I get -4, +4. Okay, for that point. The next one is 1, 2. So I got the point 1, 2. First thing it does is what? Stretch. So it's going to go to 1, 4. And then what happens? Reflects over the x-axis. So it's going to make it go to 1, -4. You might want to draw in at each point the line segment, because sometimes if you draw all 4, if there's been a lot of movement, it might not be obviously what order you go. So you got that. Next one is 3, -1. So 3, -1 stretches. That means it goes to 3, -2. Reflect. It'll go to 3, +2. Okay, so you got that. And then the last point, what is it, 5, 4? All right, so 5, 4, where does that 5, 4? Where does it stretch to? 5 what? 8. And then when it reflects, it's going to end up at 5, -8. So it's going to look something like that. Okay. You could have, anybody see a different way to go about this one? There is a little bit different. It would accomplish all the same thing. You could just multiply, just think what happened. You could multiply the y coordinate by -2, and that would accomplish the same thing. Because basically it's going to take -2 to +4, 2 to -4. Now, is that always going to work, or does everybody see that? Not necessarily, but that would work in that case. All right, what does the 1/2 x do? Horizontal stretch by 2. So what does that look like for -4, -2? What does that accomplish? Where's that point going to go, Tony?
-8.
-8, -2. So it just doubles the x value. So he's going to go to -8, -2. 1, 2 is going to go to 2, 2. 3, -1 will go to 6, -1. And then 5, 4 is actually going to go to what? 10, 4. Bless you.
Thank you.
All right, let's hop down and do one of the ones down below. Well, let's just do the last one. What's going on with that thing? Okay, you got a lot going on. Oh, man. Oh, that's a roughie. All right, and it kind of, I don't like how they have it ordered, but that's okay. What does the first -2 do? It moves it which way? Right 2. So that's horizontal. Stretch or compress? There is, because what does that 2 do with the x? Compress by a factor of, horizontally by a factor of 1/2. Okay, what does this negative do? Reflects it over y-axis, and then this one reflects it over the, which one do you do first? Doesn't matter in terms of the two reflections. You can do y-axis then x-axis, or you can do x-axis and y-axis. Take you to the same spot. +1 moves it up 1. Oh, this is all right. Can we do this? What was the first one? -4, -2? Okay, which way does it move? Right 2, correct? Right 2. And now, stretch or compress. So we cut it, it compresses by 1/2, right? So it's at -2, it's going to move to negative what? 1. Now I reflect over both axes. I'm going to go over the x-axis first and then the y-axis. So it looks like it takes me to 1, 2. And then what's the last thing? Up 1. So what's that final point? It's going to be what? 1, 3. So after all of this, ends up at 1, 3. All right. Get my eraser out. Now, like I said, I'm probably going to go segment by segment here because, like I said, I'm not sure how this is going to look when we're done. Next point is, what is the next point?
1, 2.
1, 2. So I'm going to start at 1, 2. First thing says I'm going to move right 2. Then I'm going to compress it. Ooh, so where's that going to end up at? 1.5? So I'm going to erase this first one. And so it's going to be 1.5, 2. All right, I'm going to reflect over the x-axis, over the y-axis. So it's going to put me from quadrant 1 to quadrant 3. And now what's the last thing I'm going to do? Up 1. All right, I am going to list these points because that's kind of be important. So I got 1, 3, and then what is that? That is 1.5, right? -1.5, -1. And so I'm going to connect there. I can't. All right, you try point 3. Let's see where you end up at. And that is 3 negative 1, right?
Mhm.
3 negative 1. All right, see where you end up at. All right. Where's it end up? Katie, where'd you get it at?
I had -2.5, 2, but I might have done it wrong. I don't know.
Negative 2.5, 2. And you might have done it right.
Mhm.
We got any confirmation? Yes, do you think?
Yeah.
All right, so what do we have? 3 negative 1, right? Right 2, which takes you to 5.
Mhm.
Compress it, which takes me to 2.5. Reflect up, reflect over, and up 1. So yeah, I got that point.
No
Way.
way. Okay.
And last point. Anybody got it? Matthew, you got it?
Yeah, negative 3.5, 3.
Negative 3.5, positive 3?
No, negative 3. My bad.
Negative 3. All right, good. So negative 3.5, 1, 2, 3. Okay. So when you're done, it should look like that. All right, this is your work. Just finish that. Okay, go back up. If you get done or if you get stuck, or if you want to see anything, I got some answer keys up here. All right, I'll just put them on this table if you want to just double check. I'm going to hand out your quizzes. Quizzes were okay. There's some people that struggle a little bit at times. So one good thing is a quiz. It kind of lets you know what's going on for the test. You're going to have to fix that. I do need to recollect these, but because I haven't put them in Canvas yet. Let me hand those back out, and then I will recollect them. Oh, I got it. Okay. All right, Larissa. Brandon. Lizzie. Anthony. Matthew. Pete. Jordan. Oh. Dakota. Holly. Adam. Marshall. Logan. And